Hey guys, and welcome to my channel. This lesson is about understanding quadratic functions and some important characteristics of them. So we have to know three forms for quadratic functions. My first form is standard form, which is f of x. Remember, f of x is just a fancy way of saying y is equal to ax squared plus bx plus c. Ax squared is my quadratic term, bx is my linear term, and c is my constant. My second form is vertex form. F of x is equal to a times x minus h squared plus k. And my factored form, f of x is equal to a times x minus m times x plus p. If we notice, each form has that a. All right, so I have a table here, a table of x and y values, and I plotted them on this graph. So that we have 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, and 4, 1. So I plotted these points, and then I connected my dots to see what kind of shape it would make, and it makes a U shape. This U shape is called a parabola. And now let's talk about how this parabola is facing. And this parabola is facing upwards. I like to say upwards because it looks like it's making a smiley face. So this parabola is facing upwards and it opens up. All right, let's talk about this next parabola. X and Y values, and I just plotted them to see what kind of shape they would make. And I have negative 5, negative 2, negative 4, and 1, negative 3 and a positive 2, negative 2 and a positive 1, and a negative 1 and a negative 2. And then I connected the dots to see what kind of shape they would make. And it still makes a parabola, but this time it's just facing downwards. And I like to say that it's facing downwards because it looks like it's making a frown. Therefore, this parabola, when it's facing downwards, it opens down. All right. Parabolas are symmetric about a central line called the axis of symmetry. The axis of symmetry is a line that cuts the parabola in half vertically. So that means that it's going to be a vertical line that cuts the parabola in the middle of it. And we know when we cut something in the middle that on each side it should be the same. And it always cuts it on the x-axis. So your axis of symmetry will always be x equal to some number. All right, so here I have a parabola. This parabola is opening up and it's facing upwards. And we know it's facing upwards because it looks like a smiley face. So this purple line is the axis of symmetry. It is the line that cuts the parabola in half. But where does it cut it in half on the x-axis? At 0. Well, what about this parabola? It's still a parabola. It's still making a U shape. This time it's just facing downwards. And I like to say that because it looks like a frown. This purple line is my axis of symmetry because it's cutting it in half. But where on the x-axis is it cutting it in half? Negative 2. And my last parabola is facing upwards because it's making a smiley face. And I already drew my little purple line in the middle of it. So where is it cutting it in half on my x-axis? Positive 3. If we notice, My axis of symmetry only touches my parabola one time. One time and one time only. The axis of symmetry intersects the parabola at only one point. That point is called my vertex. With my vertex, I will have a maximum point. Maximum meaning the highest point. My maximum is my highest point. And when I say highest point, that means how high does the actual graph go? And my parabola will look like this when I'm talking about my highest point. And then we have my minimum. Minimum meaning the lowest point on the graph. And when I say minimum, my parabola will look like this. The vertex is where the range of values begin. If we remember talking about the range, my range are my y values. So when I'm talking about my range and my vertex, whatever my vertex is, my y value will be greater than that number or either less than that number. All right, so I have a quadratic function here. This quadratic function is facing upwards because it's making a smiley face. And I already have an axis of symmetry. My axis of symmetry is here. So what is that axis of symmetry? 0. So my axis of symmetry is 0. Remember, the axis of symmetry only cuts the parabola in half at one point. This red dot signifies that one point. So my vertex is going to be a x and a y value. Well, look at this point. At this point, x is 0, which is my axis of symmetry, and y is a positive 2. All right, let's talk about our domain. My domain, if we remember, are my x values. And it is how far left and how far right does my graph go. Well, this graph has an arrow on the left and an arrow on the right. So this arrow on the left says that my graph can keep going left in this direction forever and ever, or it can go right in this direction forever and ever. That means that it covers all numbers from left to right. So my domain will be all real numbers. My range, well, we know my range are my y values. And my range means how far down and how far up do my values go. Well, it looks like my y starts right here at this vertex. So my y values start right there at that vertex. And where do they go? Do they go down? Nope. Do they go up? Yes. So if they go up, that means my range is y is greater than or equal to, if we're talking about the y values, 2. All right, let's look at this next parabola. It's facing down because it looks like it's making a frown. And my axis of symmetry is always going to be x equals some number. And it crosses it on the x-axis at -2. All right, this line only hits this graph with one point. That one point is my vertex, this red little dot. Remember, my vertex is going to be an x and a y value. So it crosses the x-axis at -2, which is my vertex, and the y-axis at 0. My domain, we're talking about my x values, and we're talking about how far left to how far right does the graph go. Well, got an arrow here and an arrow here, so that meaning it can go left in this direction forever and ever, and it can go right in this direction forever and ever, meaning all real numbers. Or negative infinity to positive infinity. Well, my range, we know is my y value, so how far down to how far up does my graph go? Well, it starts right here at my vertex. We're talking about the y values. So my y value is stopping at 0, starting at 0. Is it going up? Nope. Is it going down? So if it's going down, that means that my y values are going to be less than or equal to this point, this y point, which is 0. And those are some important characteristics of quadratic functions that we need to know.